So what he's saying is, quit trying to use algebra for this. You got it. Oh, we had a question? Sure, okay. And so we had to switch to using calculus and statistics so that we could say where we're likely to find an electron. So an orbital is defined as where we're 90% likely to find an electron. It's got these nice, pretty pictures. Notice this is actually 0 right in the nucleus. We're not going to find the electron in the nucleus. So let's simplify these models down a little bit. I have to watch that on the screen. You guys can't even see the yellow here. All right, so this is a simplified solution for what we're dealing with for these electrons. And what we actually get here, this S, P, D, and F, those describe the shapes that we get for some of our answers. So when we're actually referring to where an electron is, we use what's called quantum numbers. And there's a bunch of rules on those that we're not going to worry about. Now, MS, can you see over there, just a little bit cut off. All right. But what we want to know is it takes 4 quantum numbers to know where an electron is. N is the distance. It's the energy level. It's back to Bohr's model. Which outside layer is it on? L tells me the shape. In other words, which row am I on? M tells me the orientation. The more complicated the shape, the more complicated the orientation. What that's really telling me is which picture on which row am I looking at. Now S tells me the spin. It's more closely related to the electrons can spin right-handed or left-handed. But for us, we're going to think of them as going clockwise and counterclockwise. It'll make these rules easier to keep up with. All right? Now, why we have 4? Well, we use the same kind of sets of information. Let's say I wanted you to run out to my car and pick up something for me, and it's not one of these pandemic days where the parking lot's empty. I can say, yeah, my car is that way. Go behind it. It's the only car out there. But usually, you got to worry about it. First thing I'm going to have to do is tell you which parking lot, right? Then I'm going to tell you which row you drive down. Now, if I was drawing you a map, I would show you, here's the rows of the cars. But when you're actually driving, you care about where the cars aren't. And that's what you kind of think of as the row, right? Which means that as you're driving there, you've got rows on, you got some cars on the left and some on the right. You know which side you're counting on. Okay? And then you'll need to know how many spots to go down. When you get there, is there going to be another car in the same spot as mine? No. Okay. And the same is true for these electrons. And so that is called the Pauli exclusion principle. And it's easy enough. It says no 2 electrons in an atom have the same 4 quantum numbers. Come on. Put a light on for a second while I talk so they can read it. It's my camera just. All right. No 2 electrons in an atom have the same 4. In other words, you can't put 2 cars in the same spot. All right, so these letters, S, P, D, F, you have to memorize those in order. After that, what's great about this system is when they define the rule set for these, And it's really based just on, the rules were based on the math, which happened to match what we see in nature. Is we can extend this infinitely out. And so when they did these SPDF, it's really, the L values are 0, 1, 2, 3. The next one is going to be 4 and 5 and so on. So after F, they go alphabetical. G, H, I, then they skip J because it's not in every alphabet. So they skip J, and we keep going. So I just got the first 4, but the next one down is going to be even more. Okay. All right, let's see, orientation. This first one, let's see, the S, I didn't talk about what the S stands for. The S looks like, it's actually based off of the stuff from the shapes of what the signals we see in radar. And so there were multiple different types of signals that you would see on a radar screen. And so you had real sharp signals and some kind of weird peak things and who cares and I don't know. Because we're not going to memorize them that way. All right? Now, you can do it the smart way or you can do it the way I did. When I did, I said, man, I wish I was at the beach. But when I go to the beach, I got to wear a lot of sunscreen, especially now. My legs get burned. I sure can't afford my head to get burned. Get the feeling up there. Everybody look at you funny. All right? So when I go to the beach, I need sunscreen. What do you care about for sunscreen? How do you know if it's the good stuff? The SPF. That's 3 out of 4. That's it. All right, so these are the L values. I don't know why I wrote it in green so they can't see it. It's a little, I'm going to get blue. We'll use the black. So these are our L values. Now, each one of these pictures is called an orbital. So let's just count the pictures. How many S's are there? How many pictures of the S's do we have? 1. How many pictures do we have of the P's? 3. How about of the D's? 5. And then maybe you see the pattern, 1, 3, 5. These are the odd numbers. And so when I do the F's, I expect there to be 7 of them. And there are. When I do the G's, there should be how many? 9. And then the H's, there's 11. Now, because of the way the math works out, the S is actually only, when I had my quantum numbers, that spin number only had 2 options. It had a plus 1/2 and a minus 1/2. We're going to think of them as clockwise and counterclockwise. Now, do I want 2 of them going the same way? Why not? Oh man, you guys are forcing me to be mean. Yeah. See, we got more girls than guys today. All right, girls, I want you to think of cheating ex-boyfriend. No good. Everybody seems to have one. Huh? You're going. Be careful of that because I'm saying we're going to be on the road today, and so you may be tempted to run into each other. But you're going to pass him on the road today. There's 2 ways you can pass somebody on the road. One, you're driving one way. He goes driving by the other way. Oh, there's that no good. Right? Or you can get stuck in traffic. He's 1 lane over and you're going at the same speed. Which one is more repulsive to you? Same speed, same direction. Yeah. Yeah. Electrons, remember, negative charges. They repel. The last thing they're ever going to want to do is be going the same speed, same direction. Okay? Now, it's bad enough if I got one going this way and one going that way. They kind of go, zoom, oh, I hate you. Then they're gone. All right. So if I put one in and it goes this way, and I put one in and it goes that way, can I put a third one in? Well, it would have to either go this way or that way. And that's no good, right? So how many can each one of these pictures hold? Maximum, 2. So each one orbital holds 2 electrons maximum. One orbital equals 2 electrons maximum. They can sit empty. They can sit empty. They can sit there with 1 in them, but they can only ever hold 2. In other words, each one of these pictures could only hold 2. So my S's, how many electrons total can fit in my pictures for the S's? Well, I only got 1 picture, so how many electrons? 2. How many can fit total for my P's? Well, I can put 2 in here, and 2 in here, and 2 in there. 6. How about for the next one? 10. You notice I quit looking over there. I started looking at my chart. What am I going to do? No. Let's get full. Add 1. Yes, but it's even easier than that. Multiply by 2. What by 2? Number of orbitals. Each one holds 2. Just take that number and multiply by 2. Okay, you got real close to the same answers. Sometimes add 4, yep. But that just happens because those are going up by 2. So now this one will be 18, 22. And we can keep taking that as far as we want. Because we know the pattern.